Morning, everybody, and welcome to this screencast on using the online graphing calculator known as Desmos. So remember, Desmos is web-based, so you can find it on the internet. And if you have an iPhone, you can also download the app and use it there. But depending on what you're doing, if it's more of a project or an assignment that you need to do, then it's probably best to use the web-based version on a tablet or a computer. So last week we covered a little bit of how to use it, but I thought I'd give a run through of how to continue using Desmos. So last week we were adding an item and it was a table, because the notion was to substitute in the data we collected from a particular activity. So this was an activity meant for Fathom, and it can be used in Fathom and also here. So it's going to scroll through, and there was some of the data. Okay, so what you would do is you would take that information and plot that in to the graphing space. So we have 0 and 5, and over here on the y, 179.5, followed by the other value, I believe was 168.7. So I'm not going to put them all in here, as I've already done that. So just to give you an idea of what you're looking to do. Now notice over here on the graph, I'm just going to hide the keyboard for now, is that you can't see the values. And having a look at the y values, they are large enough to tell us that we need to zoom in order to pull in those larger values. So there you can see the two plotted values. Okay. So now that that's done, what we're going to do is I'm going to show you, I had already created, as we did in class last time, was that particular graph. It's going to take a moment to load that, and here it is. So I'm going to open that graph, and that's another great feature with Desmos, is that over here up on the upper right-hand side, and I'll show you in a second, it gives you the option to create a free account. Okay, so up here, I guess, when you're using the desktop version and you haven't created an account, you can sign up. It's free. They don't send you any information. It's purely on an educational basis. And the great thing is you get to save the graphs, much like I have over here. You take a look. These are all the different graphs that I've been using this year with a variety of classes. Okay, so let's head back into that. There we go. So all the data is here. It's in the list. Okay. And then another feature you might notice is I'm just going to turn off these plots. So if I click on that, it removes the scatter plot. So another thing to do as well is notice how there are several pieces of data that have to be entered in by hand. One thing you might try to do is, if you have your document available electronically, is to highlight the values. So I'm just going to right click and copy. Go back into Desmos, and then up here, what we're going to do is we're going to specify a new table. And with that cursor within that space, I'm now going to Control V, or attempt to paste in the data. And notice what it does is down here, it gives us a third relationship. So it's bypassed this one. I'll get rid of that. And we have this relationship here that has pretty much all of the data. It's only missing the first point. So I need to enter that down. And well, it seems to be out of order, but that doesn't necessarily matter because it's going to plot the point accordingly anyways. And you can see how, if I take that out, how it plotted it immediately where I needed it to be. Okay. So that duplicates the data we have here. If I turn that back on and I turn the other one off, I should get the same graph, but in green points, okay, as opposed to the black. So that's a quick way to transfer your data or to import your data into Fathom, especially if you have a really big list of data. Okay. So what we're going to do now is we're going to apply the curve of best fit. So that was done last week. So here we go in review. I think what I'll do is I'm going to remove these items here. I'm going to turn these plots off. And what we'll do is we'll take the other data just to prove a point. So I'll take this data set. And now what I'm going to do is to insert an expression. Okay, so that is to insert an equation. So I'm going to put in the equation y equals, capital A was the y-intercept, multiplied by b to the power of x. Now the power of x, that particular key, I'll just show you here on the keyboard. That key is this one here, a to the b. Much like on your calculator, it's y to the x, but here it's a to the b. Notice that it asks to add a slider for a, but not for b. So it should be asking for both. So I'm going to go back and see if it's case sensitive. So it's not prompting me to add a slider, which is what I need to have. So I'm just going to go back in here and see if I can determine why it's doing that, because it really shouldn't be doing that. Let's see if I can apply them here. No, it's not. Although it seems to have added the information in, and that's because I already have pre-existing sliders. So I'll take those out just to prove a point. And back here, great. It's going to ask us to add sliders. So those are dynamic tools that allow us to change the values. You can see here the values of A and B. Notice I have a blue line here, a flat line, that is moving up and down. That's to approximate the y-intercept. So I'm going to take that up to 180 for now. And you can see how it's brought the line up to 180. Now the b, that's going to be our growth or decay factor. Now given that this is a decay curve, or we expect a decay curve, that should be a decimal value between 0 and 1. So you can see how the graph is now decreasing at quite a rate, quite a strong rate. So we're going to have to see if we can bring that up a little bit more. So we want this graph to decay, okay, not at quite a fast rate. Now, this might look a little weird, but I'm putting in 0.9, okay? Now, 0.9, what that means is it implies a 0.1 or a 10% rate of decrease, whereas the factor is 0.9. Okay, that's the relationship between the decay factor and the decay rate. So it's not bending quite enough. So I'm going to put in a decimal place, 0.9555, and you can see it is starting to move its way up, but not significantly enough. Let's try 0.965. Again, not quite. Go away 0.975. We're getting there. 0.985, very close. Very close. If I move the y-intercept up a little bit more, you're going to see a better fit. Okay, I'm going to reduce that a little bit, and then I'm going to increase the precision of my curve, and that seems to have brought it up way too high. I can drop the y-intercept again. 180. Not bad. Go 178. And not great, so it's probably better off that I do keep that at about 0.985 or increase the precision on that. So you get the point. There's 0.987. Not bad. That's a fairly good fit. Okay, so what you would do then is you would, I'm just going to create a new sticky note here up in the side. What you would do is you would then, on your sheet, is to record the values and then the equation for that exponential decay curve. So that would be a y-intercept of 178 and then a decay factor of 0.987, and that's to the power of the exponent x. And now you can use that equation, do some substitution, and do some solving, and you'll be able to determine this problem was all about coffee temperature. Okay, so x was the time, y was the cooling temperature. So I can go back and answer a few questions.